Semantic Kernel is an open source SDK which was developed by Microsoft that enables developers to build AI powered agentic applications by providing the ability to interact with large language models, provide symbolic reasonings, also have capabilities like plugins, memory, skills, planning, and execution. Now, these are the key features of semantic kernel. It's available in multiple languages as a library. And to give a little bit of view of the semantic kernel, the kernel is at the heart of the framework. And any application that interacts with the kernel is responsible for selecting the appropriate AI service, rendering the prompt, invoking the AI service, invoking the underlying model, parsing the LLM response, and creating function results. And each of these different steps pass through the kernel, which means that you also can build in a layer of observability between your application and what is the kind of message exchanges that is happening at the kernel level. So that is the crux of semantic kernel. Now, recently we announced the availability of semantic kernel agent framework. Now, the agent framework provides a platform where you can create agentic AI architectures where you can either do a single agent system or a multi agent system or a hierarchical agent system or any kind of agentic patterns that you want to implement within the Azure AI platform. So the semantic kernel agent framework has recently been made available for users. Now, the benefits are while it definitely helps to build multi agent systems, it also is modular in nature. It also provides capabilities for human interaction and human collaboration. And definitely, you can orchestrate multiple agents together. Let's say I want to build an agentic system for resolving queries on a e-commerce platform, and there is a billing issue that has happened, and I am requesting the triage. I'm contacting the triage agent. The triage agent is equipped with two more agents. One is the billing agent and the refund agent, and any information that is required from a billing standpoint is handled by the billing agent, and the refund agent takes care of the refund. So if let's say I want to build an ecosystem of agents like this on semantic kernel agent framework, this is how I would do it. So I installed the required libraries and I have loaded the environment variables. And as you can see, the kernel is defined. And to this kernel, I'm now adding or I'm actually configuring a billing agent. This billing agent handles issues with respect to billing queries, and the instructions have been given to the billing agent. On the same lines, I have a refund agent. The refund agent is specifically created to address issues with respect to refunds. And to the triage agent, I am providing the billing agent and the refund agent as plugins. And now the kernel framework understands how and when it needs to invoke which particular agent. So let's see how this runs. So I'm saying I was charged twice for my subscription last month. Can I get one of those payments refunded? Behind the scenes, the billing agent is invoked and the refund agent is also invoked. Why is the billing agent invoked? Because it is looking for, because there was a dual transaction that has happened on my account, and it is asking me for some response. It says, could you confirm the date of charges and the amount that was debited twice? Do you have any transaction IDs or receipts for those charges? So I provide the information. I say 10th April, order number 1000, $100, so and so at this particular time. This is the information I provide the agent. When I say help me with a refund, even though I am talking to the triaging agent invokes the refund agent, and the refund agent now picks up the task of which product are you seeking the refund for, when did you make the purchase, and tries to look for additional information here. Now, behind the scenes, if I hook this up with an e-commerce system data source, which pulls up the transactions data as well as the processing data, it can validate the user input and seamlessly the coordination is handled between the three different agents here. One is the triage agent, the other is the billing agent, and the refund agent. So without any additional configuration, these two agents are registered as plugin, and the triage agent knows when to invoke which agent depending on the scenario. So it's pretty easy to build agents using the semantic kernel agent framework.